Okay, whenever they're giving you stuff like this, there's always a couple of things that I always start with just because generically it helps you. So the first thing you always want to do is graph the angle, graph the point, whatever they're telling you to graph. Okay. So once you do that, you have this. The next thing you're going to do, actually, you tell me, what's the next thing you should do? So this one's going to be draw right triangle to the x-axis. People like to draw this to the y-axis. Why? I don't know. So here goes this. I'm going to draw this. And I just take the elevator up. Boom. Does everybody see my right triangle? Yeah. Okay, good. So then the next thing that's going to be, hold on. The next thing that I want you to do is label your triangle. Okay. So we're going to label this triangle, and all you're going to do is you're going to go in here and say, oh, this went this way too. It went down -2. And then you have to figure out your third side. What are your two tools that you can use to figure out your third side? Sorry, I was. Does that make sense? How do you find this third side? What? Yeah, Pythagorean theorem or what? What's the other way? Yeah, or 30, 60, 90, or 45, 45, and 90. Collectively, those two are called your special right triangles. Now, someone already put in the chat that this is a 45, 45, 90. How did they know? How did they know that this is a 45, 45, 90? Like, what told them? Yeah, these two sides match. Miss Johnson, they actually don't. This is a 2 and this is a -2. These two sides are congruent. Okay. So if that's the case, then and you've memorized your 45, 45, 90, you know this is 2, 2, and this would be 2 root 2. If you haven't memorized those and you're planning on going to calculus or pre-calculus next year, please do. Please memorize those. Okay. Okay, so then the next thing that I'm going to do. Oh, okay, that's all I want to do. Okay. So label your triangle, that's done. You're going to find all kinds of information when you label your triangle. You guys told me, which I forgot to write, that this is pi over 4. This little pi over 4 in the triangle is called your reference angle. So the reference angle lives in your triangle. Always. Always lives in your triangle. So this guy, he lives, just one L. Okay. So in this case, sometimes you're not this case. In some cases, your right triangle and your other angles are exactly the same. So let's continue. Then state the angle theta. The angle theta is this guy, right? If you take, no, I'll use a different color. Purple. So you close the book is closed, then you open the book all the way around here. That is your theta. So that's theta. This is theta. So if you know this little guy is pi over 4, would you be able to figure out what theta is? If you knew that this little guy was pi over 4, would you know what this angle is? How would you figure that out? Yeah, very good. Or talk to me in pi, right? Like someone. Oh, am I cutting out for you guys? A little? Uh-oh. Hold on a second. Dang. Is it cutting out now? Do you want me to keep talking to check? It's not cutting out. Okay, good. Okay. So, if this whole thing is 360 degrees and you know this is 45 degrees, then yeah, it's just 360 minus 45. Now talk to me in terms of pi. If this whole thing is not 360, how much is it in pi? How much is it in pi? How do you say how do you say 360 in terms of pi? The whole thing. Yeah, it's 2 pi. Very good. That's the correct answer. Okay, if the whole thing is 2 pi and I took a piece of pie away, how many slices do I have now? So the way my brain goes is goes like this. Can you all imagine that there's pizza in front of you and we decided to slice each pizza up into 4 slices? So this part here represents 4 slices. This part here represents another 4 slices for a total of 8. And then you took a slice away and ate it. So how many do you have now? 7 pi over 4. Okay. So let's write this down. I didn't even write this down yet. So reference angle, oops, let's just go alpha. Alpha equals pi over 4. Okay. Theta equals, in this case, it's 2 pi minus pi over 4, which equals to 7 pi over 4. Everybody comfortable with that? 7 pi over 4. Good math on that. Can you give one equivalent positive beta that's equivalent to this? So sometimes we will call these coterminal angles. Beta is just another Greek letter. So, like, I need you to imagine that you're on a spinny chair. Everybody on a spinny chair? I'm trying to choose a color here. So let's pretend you're on a spinning chair and I spin you around and around and I stop you here. So where you stop is just where you stop. But how many times you went around, that would be another example of beta. Does that make sense? So let's say that you didn't stop here, you continued. So you started and you went all the way around. How much is that? How much did I go around in the blue angle? Yeah, it's 2 pi. But then I kept going. And then I stopped here. So this angle I'm calling as beta. How would I calculate beta? How would I calculate beta? Yeah, it's 2 pi plus 7 pi over 4. Very good. Yeah, someone said 3 pi. I don't understand what you're saying. It's 2 pi. It's a whole circle. So remember when I started here and I went all the way around and I stopped here and I said, how much is this? You guys said 2 pi or 360, right? And then I continued on for another 7 pi over 4. So for me, this is 8 slices of pizza plus 7 slices of pizza makes 15 slices of pizza that were cut into 4. Does that make sense? Everybody
Yes.
comfortable? Yeah.
So you said a whole circle is equal to 2 pi.
Mm-hmm.
So if you
Yes.
did one whole circle and then the half circle, wouldn't it be 3 pi?
So watch my blue, right? So this whole part is 2 pi, right?
Okay.
And then you said this is 3 pi, right?
Uh-huh.
Which is true. And then you went like this, and then you said 7 pi over 4. Right? Which is not. 7 pi over 4 is your purple angle right here. 7 pi over 4 includes your pi. Does that make sense?
7 pi over 4 includes your pi.
If I had 7 slices of pizza, how many full pizzas do I have if I cut it into 4? Like if I cut a pizza into fourths and I had 7 slices, how many full pizzas do I have?
Like 1 and
1.
7.
So that one that you just said was this one, right? Or this purple one, whatever one you want to talk about. Another way to check your answer is go 15 pi over 4 and then just start counting. If you started here, how many would this be?
1 pi.
Talk to me in slices of 4. How many slices of pizza would this be?
4.
Good. How much would this be?
8.
And this?
12.
And then 13, 14, 15. Does that make sense? or 12, 16, take away 1 is 15. Does that make sense?
Yeah, kind of.
It just takes some time to get used to it. I will tell you, anybody who is like laboring with me in this right here, and I see you guys, I see you laboring. Just make sure that you're comfortable with this, positive and negative, because this is, if I was going to pick something that was really important from last year, it'd be this for you to be successful next year. Okay. So this is beta. So Miss Johnson, could I have added 4 pi to it? I don't know. Let's try. Let's go with green. So 4 pi looks like this, right? Here's 2 pi. Here's 4 pi. And then plus 7 pi. Well, that's plus the purple angle. So just end up where the purple ended up. Yeah, that's good. So in reality, for those of you who are making sense of this, I can add as many circles as I want. Isn't that correct? Everyone's like, yeah, I can. So sometimes you'll see this in books. It'll be 2 pi n. So we'll just write it as 2 pi n plus 7 pi over 4. 2 pi n means a bunch of circles. Am I comfortable? All right, good. Okay, beta as a negative angle. So this whole time that we've been talking about angles, we've always been going in this direction. We open the book this way. Everybody okay with that? What happens if we go in the other direction? Now, mathematically, think about this. Mathematically, think about it. If we go in the opposite direction, when I say opposite, what kind of numbers are you thinking about? Negative. Very good. Very, very good. So negative, if I go in the opposite direction of counterclockwise, if I go this direction, I need to find a color. Hold on a second. Maybe this red color, because red means negative. If I go in this direction, this is negative. Okay. So if I want to write a B prime negative angle, right? So this is beta prime. I just go negative something. How much is this angle right here? How much is this angle? What's this angle right here? Yeah, it's pi over 4. Very good. So I'm just going to write pi over 4, and then I'm done. And if you want to be fancy, you can go in a bunch of circles over and over again in the clockwise direction, and then stop here, right? So you can add if you wanted to. So just so that we're clear, I could add 2 pi n again, 2 pi n, and then minus pi over 4. Over 4. Where here, I should have said that n is whole number is in the whole number set, versus here n is a negative number. Because we want to get a bunch of negative circles, right? Right. Let me see. So whenever you're graphing these, don't get confused. You're just finding where they go. I really like when you think about it as pizza and you're thinking about it as whole pies, 2 whole pies, take away a pie, add a pie. That helps you with your fractions. Okay.